So if you're still listening right now, I assume that you're interested in doing some challenge problems. A lot of what we were doing the last couple of days was looking at code and trying to understand how it works. And the IP that you completed is what I call kind of like row and column dependent. Now, when we're looking at 2D arrays, the usefulness of them is that we can kind of like we're interested in processing things depending on where they're at. We can use them to kind of analyze a value, either a string or an integer, depending on the space that it's in within the 2D array. And we really looked at how to analyze and understand some of these pieces. But this gets a little more fun when we get to write this code ourselves. How can we look at something and analyze the amount of, analyze its location and how it's affected by its value? So we're going to do 2 challenge problems today that take that on. For both of these, I'm going to pop them up. I'm going to have you pause them and try them yourself. See what you come up with, and then you can check it against my answers. This is really just for fun. You don't want to complete this, it's fine. But it'll give you a jump for this type of stuff that we're going to start talking about on Tuesday. First things first. Write code that manipulates a 2D integer array in the following ways using our double for loop code. Count the number of entries that have a greater column and index than a row index. One way to think about that is that if the column number is greater than the row number, let's add something to the count. Go ahead and pause your video, see what you can come up with, and I'll be back in a few to tell you how I would think about this problem. I'm going to complete the problem for this in your note sheet. Underneath this little section, it's before the start of your IP. It says challenge problems. Writing code that depends on row and column understanding. So we want to count the number of entries that have a greater column number than row number. Keep in mind that in the master copy of your notes on Haiku, these solutions are laid out for you. You're welcome to copy it into your own if you'd like to. We'll assume we have some sort of integer array named numbers. And that these are going to have to be filled in with row and column size. This is a good opportunity to stop and make sure that you're comfortable with our double for loop code. See if you did the same thing as me. We'll loop through our rows. Loop through our columns. Remember, we said that inside of this code, we were going to count something. So I'll define a little variable at the top. It'll keep track of the number of entries. I'll count it. And here's where this starts to get interesting. I promise it's interesting, even though I'm yawning. We want to check and see what has a greater column number than our row number. And we can do that using these variables that we define. So this is y is our column number, and x is our row number. We can put in one little if statement. That checks that out for us. And if it is, we'll add it again. So hopefully you're feeling good about that one so far. This is a little situation where now we're using our indices to think about the conditions of things. And it allows us to think about where a value is within the code. Number 2 is where this starts to get a little more fun. Write a method that returns true if the array is identical along its array or along its diagonal for 2D int numbers. So let's take a look at what that means. We'll call this the diagonal. 1, 2, 3, 4, 5. And the idea of this is that the numbers across the diagonal are even to each other. So 2, 2, right? This is 1, 0. This is 0, 1. They're equal to each other. This is 2, 0. This is 0, 2. They're equal to each other. They're both equal to 3. This is 3, 4. This is, or 3, 4. Yeah, right there. 3, 4 is right there. This is 4, 3. I'm sorry about that. 3, 4 there. 4. Value 4. I'm sorry. 3, 0, 1, 2, 3. 1, 2, 3, 4. There's 5 right there. 0, 1, 2, 3, 4. 1, 2, 3. 5 along that diagonal is equal to 5. So when you flip the indices, the idea is that they should be equal to each other. So how do you make something that works like that? I'll give you 2 hints. I want something that's going to be even along the diagonal. Make sure that the flipped indices are equal to each other. And number 2, it's going to be easier if you use a Boolean. Check if it's true. And it's honestly easier to check if it's not true. Pause your video. Try to figure it out for a couple of seconds. Then see what you came up with and check it against the answer. First things first. Doesn't matter how big this thing is. Let's assume it's square though. We'll assume it has an equal number of rows and columns. I'm going to find a Boolean and I'm going to set it equal to true. Remember I said it's easier to check if it's not true? Assume it's true at first. Because if there's one individual space, if there's one space where the pattern doesn't align, we can switch to false. Next, I'm going to use the same for loop setup that I used last time. Now the question is, what am I checking for? What we're going to check for is if the flipped indices are equal to each other. Remember, number is xy. will give me the value at that particular space. And yx will give me its flipped index to check it against. And I want to check and see they're not equal to each other. Because we can assume it's true, and then the moment we find that they're not equal to each other, all we do is check it to false. Find one instance where it's not true to be the case, problem solved. Thank you for joining me on this little additional journey. I hope you've enjoyed looking at some of these problems that involve a little bit more complex indexing. And let me know if there's anything else I can do to help y'all out. I have office hours available from 2 to 4. Shoot me an email over the weekend if you need anything, if it's after that point. And we'll be back together on Tuesday to start writing some more complex code for 2D arrays and kind of wrap it up before our spring break.